The summary below is written by a real AI model.
In Part 1, our program returned a summary from a fixed template. In this tutorial, we connect that workflow to a real language model. The local tool still supplies the approved information, but the model now generates the summary and recommends a practical next step. Welcome back to TD SASH, where we build practical projects using artificial intelligence, Python, and software development. Let us continue. In Part 1, Research Workflow did two jobs. It called lookup knowledge, then inserted the result into a fixed summary template. Here, we keep the lookup step unchanged. Instead of building the summary in Python, we send the topic, the approved research data, and a set of instructions to a language model. The model returns two values, a beginner-friendly summary and a practical next step, and we place both inside the same response dictionary Part 1 already used. Before writing code, install two packages, OpenAI and Pydantic. You will also need an OpenAI API key. Create one in the developer dashboard and store it in an OpenAI API key environment variable, which the OpenAI client reads automatically. Never place a real key directly in your code, and never show one on screen. Let us start with the function from Part 1, completely unchanged. It normalizes the topic, searches the local dictionary, and returns either an approved result or a fallback message. Keeping it unchanged gives us a clean comparison with Part 1. Import the OpenAI client and Pydantic's base model, then define generated research response with a summary field and a next step field. This is an explicit contract. The model can generate the wording, but Python always knows which fields to expect. This is better than asking for free-form text and splitting it manually. Generated research response has a fixed, structured shape, even though its content is dynamic every time the model runs. Now, create Generate Model Response. It receives the topic and the result from our local tool. OpenAI builds a client that reads the API key from our environment variable automatically. We never type it into the code. The instructions parameter tells the model its role and boundaries, explicitly limiting it to the approved research data we supply, nothing invented. The input carries the topic and that data, and text format tells the SDK to parse the reply into our generated research response structure. If no parsed response comes back, we raise an error instead of pretending the call succeeded. Every request carries the same 5 things: the model, its instructions, the topic, the approved research data, and the expected output structure. Nothing else reaches the model. Update research_workflow, keeping its name and dictionary shape. It still calls lookup_knowledge first. If no approved information exists, it returns immediately. We never send an unsupported topic to the model. When research data is available, the API call sits inside a try block, so a failure returns a controlled error instead of crashing. 3 paths through this function. No research result returns a safe fallback. An API failure returns a controlled error. And a successful call returns the model's generated summary and next step. Add a small print response helper to keep the terminal output tidy. Then an entry point that runs the workflow on the same AI agent's topic we used in Part 1, making the fixed versus generated difference easy to see. Let us run it and see exactly what the model generates. Running Python main.py with the topic AI agents. Example output, exact wording may vary. The research text still comes from our local dictionary. The summary and next step now come from the model. The returned object always has the same summary and next step fields. Now, confirm the unsupported topic behavior still holds with quantum agents. The request stops before generate model response is ever called. The model is never asked to fill a gap in our approved knowledge, which lowers cost and risk together. Our project now combines deterministic Python logic with generative model output. Python controls input handling, selects the local lookup tool, checks its result, executes the API call, and handles failures. The model only receives approved information and produces the summary wording and the recommended next step. This is a genuine model-powered workflow, but it is still not a complete tool-selecting agent. This workflow still has real limitations. Only one local knowledge source, no memory, no repeated decision loop, and no ability to choose tools. Structured output guarantees the expected shape, but it does not guarantee every generated sentence is correct. For your challenge, add one new topic to the local dictionary and compare the generated result with the fixed response from Part 1. Then try adjusting the instructions while keeping the rule that the model may use only approved data.
In this tutorial, we connected the existing Python workflow to a real OpenAI model. We added secure environment-based authentication, explicit model instructions, a structured response contract, and controlled API error handling. The project now generates its response dynamically, while Python continues to control the approved tool and decide when the model runs at all. Next, the model decides when to call the tool. Subscribe to TD Sash. See you next time.